So this morning's keynote is Tony Vellum. He started at Microsoft many decades ago, but only at Google this year. So he and I have overlapped at both of those places. And for the first 6 months of his Google career, he reported to me. And then, the whole test thing, and here we are. He is in charge of all of our cloud testing. But he doesn't call his group testing. He calls his group fundamentals. And so there's far more to this guy and far more to his group than testing. He's about reliability, he's about performance, he's about security, he's about privacy, he's about doing things right from the beginning. Our cloud platforms are a lot deeper. I think when you think of Google Cloud, you probably think of App Engine. App Engine's part of his domain. There's a lot of other stuff that is in the process of being released and is forthcoming in the Google Cloud offerings, and Tony's going to talk about the depth and breadth of all of that stuff. So welcome, Tony Vellum.
Great.
Hang on. This is an accident. It's an accident.
Yeah, you have to love a guy who hires you to a company to transform tests and then becomes a developer lead. So thanks, James. Yeah, and in terms of those cloud pins, I actually think they're like the Yeti because I have yet to see a cloud pin myself. So does anybody actually have one? Oh, so they actually do exist. I did hear somebody that flies an airplane, and she is in this room, seems to have some buttons. So if you can figure out who that is, you might track her down. So before I got in, one of the things I wanted to do was say, yeah, thanks a lot for all the great conversations that we've all had the last couple days, and in particular, a shout out to Vivek from Fin.com and Gio from Mozilla. It was interesting after Alberto's talk yesterday. We were all like, yeah, is test dead? What does it really mean? And the more we talked, we sort of came on this whole idea of test as risk managers. And it's really interesting is we've all done our job to date. The way we've kind of managed risk is we go find bugs, but there's a lot more you can do to really drive product innovation and really add a lot of value. And part of that is things like security and performance, like James talked about. It could be engaging communities on how to use your tools. And so I kind of leave that as a thought to you that, hey, maybe our job really isn't testers, but our job is really risk mitigators or risk managers and explaining to people why or why not to ship a product. And if that helps you think about your job differently, I hope it does. So with that, I want to dive into part the clouds and see fact from fiction. So what do I want you to get out of this talk today? Really, I want you to get three things. Number one, I want you to get an understanding of what the cloud is. There were discussions yesterday, but I want to give you some of the history and some foundations so that it can really shore up your knowledge base that you have. Number two, I really want to talk about cloud tests, and I say test cubed because there's really three dimensions to cloud tests, and we'll definitely cover that. And then the third thing is I really just wanted to boot Alberto and this Grim Reaper off the stage because while tests might be dead, I'm going to go through lots of examples of ways you can transform yourselves into the cloud, and actually how I believe tests is only beginning. I think the whole idea of really driving new innovation, we're just at the beginning of this. And so with that, I wanted to kick the Grim Reaper off and come in, as an angel of kind of vision. So I'm going to cover a couple topics here in the context of helping you get the three things I want you to get. I'm going to go to the beginning, like where did the cloud start and how did we get to where we are? I'm going to definitely go through some common fact and fiction, which will be pretty exciting. And then cover a little bit more detail in the cloud testing domain, and then talk about the path forward and give lots and lots of ideas on things that you might do. In fact, you can take any of these ideas and run with them. So the beginning. So when did the cloud really start? The idea of the cloud actually was first thought of by John McCarthy, who, rest in peace, died on Tuesday. He was the father of Lisp and AI. In fact, he's one of the fellows. If you go out here and look at the plaques outside the room here, he's on one of the plaques. Very phenomenal guy. And then back in 1961, he made this claim that one day computing would be a utility. And it's pretty interesting because at the time there were only 6,000 computers when he said this in the world. And this notion of time sharing was there, but only the elite could get access to machines. And so when you think about a utility, it means everybody can get access. And so he saw a time when we would get there. However, it wasn't until really 1997, and I apologize for the name, Ramnath K. Chellappa, that actually came by and tried to give a definition to cloud computing and really tried to define it as a paradigm, where the boundaries of computing will be more economic than technical. And so that was really like the first incarnation of the term cloud computing. In fact, he's coined with, he's kind of determined as coining that term of cloud computing. And then I didn't put it on the slide here, and I should have. Another thing that happened is in 2006, Amazon Web Services launched, and some see that as kind of a mark in the path to computing, which is really interesting because if you think 2006 was only 5 years ago, which gives you an idea of just how early we are into this whole thing. So what is cloud computing, and how do we differentiate it? There's a couple properties here. The first one is it's nobody cares where the resources that you're using are. And I use the term resource loosely, but it's like computing and databases. And this is only possible because we have really powerful networks today. And so that was kind of the first thing. We needed networks for cloud computing to really happen. The second thing is utility. You pay for what you use. And so if you look at the different resources, there's different models. You can pay 8 cents an hour, you can pay $5 a month, but really what you're doing is you're only paying for your piece of the computer, and sort of gone are the days where you would spend a lot of money, put a machine in your office, and you have a $5,000 machine which you use maybe a couple hours a week. The other part is it's elastic. You can sort of grow up or grow down your use of the cloud. And so if I have one user, I'm only using a little bit of the cloud, and if I have 100,000 users, your applications tend to scale up automatically to meet that demand, which is pretty cool. It has to be programmable. So all of the cloud platforms out there have APIs that you can get to, and the programmability part is a really important piece of defining cloud computing itself. And you get things like an access control model and something called multi-tenancy, where you're actually kind of co-located with other businesses that might be running with you, where you might have like a Bank of America and a Wells Fargo running in the same system. And you can imagine from a test perspective, could be very interesting. How do you make sure you don't have data leakage across these boundaries, and what are the complexities that are there? If you want to go deeper down into some more of the cloud computing terms and definitions, I actually threw out there's a expo called Cloud Computing Expo, and in fact there's another one that's going to happen in this area sometime soon called UP, so you can look for those and actually go deeper into cloud. So with that, let me put some context around cloud, because I really want you to understand what's available and where things sit. And in fact, we heard about technologies from multiple layers yesterday. So sort of in the beginning, there was this whole notion of infrastructure as a service. And so this is what IIS is. And this is really the idea that was out there of, hey, we have all these computing resources in our data center. We are ourselves not totally utilizing them. How do we get these out so others can use these resources, and we can kind of reduce the costs that we have? And so you see things like Amazon EC2 came out, where you can buy virtual machines in their data centers. You have RDS or Microsoft Azure. There's a lot of players in this tier of infrastructure as a service. And you have also Google here, where we have things like Google Cloud Storage. So you can store 5 terabyte files in the cloud and kind of push them up and suck them down from anywhere in the world, which is super fast and cool. And also, just recently, we put out into a early preview, trusted tester, invitation only, but you can request an invitation for the Google SQL service, which is part of App Engine. It puts a relational store behind App Engine, which was something we had been missing for a while. And so at this bottom piece of infrastructure as a service, you really have like compute, storage, and networking. And these are kind of maximal complexity, but maximal flexibility. At this layer, you have a lot of management headaches that you have to worry about. So if you have an EC2 instance, you have to patch the operating system that's running inside your virtual machine. You have to keep it up to date. You have to manage all of your software in this stack. And so while you have maximal flexibility, you can literally do anything, you also have this maximal complexity. It tends to be the very easiest point to sort of enter into the cloud where you're like, oh, I have a database locally running in my, my enterprise, and I just want to put it into something like, Google SQL Service, and so I can just move my database over and run it there. For sure, you can do that. But really, that's only just sort of the beginning of the power of the cloud, is this infrastructure as a service layer. So then you move up in the tier, and you hit this layer which is called platform as a service. And the platform as a service does require some rethinking your applications, and it does require rewriting some of your applications. But what you get in the platform as a service layer is you get automatic load balancing. You don't have to program this yourself. You get automatic scale up or scale down. So did anybody use the Google Doodle, the guitar Google Doodle out there? That was an App Engine app. And what was cool about that is the developers that wrote that could focus on writing that app and not have to worry about like, oh, well, what if 5,000 people use it or 4 million people use this app? They say, okay, here's my app. It goes into Google App Engine. Hey, App Engine, you control scaling up or scaling down the usage of my application. So you can see there's a lot of power there. You have less flexibility because you can't do anything you want. I mean, you have a lot of flexibility with languages like Java and Python that are hosted in this tier. But you can't do anything you want. You can't really run C programs today, perhaps one day, but not today. And so you also have other players in the space like Amazon Elastic Beanstalk or Salesforce.com Heroku. They're both Java hosting platforms as well, with similar benefits. But there are definitely differences too, and you should go look into those. And as we move up the tier a little bit further, we move into the whole domain of software as a service. And in the software as a service domain, you have the least flexibility, but you get rapid application development because somebody already comes to you and says, here's an ERP database. Just build your widgets around it, and you can use this database. And that's some of what like Salesforce.com does. And for Google, you have sets of things you can build around. Like you have the Maps API that you can use, or we have the Google Prediction API, where you can do linear regression analysis or clustering, and you basically say, here's a data set, tell me like interesting things about my data, and the prediction API will tell you those, or like Google Translate APIs. And so you can take these components and build on top of them. So you have the programmability aspect, but you don't have a huge amount of flexibility. Like you can't control the algorithm that we use for, say, Translate, or in like the BigQuery, which is a data mining capability. It's an OLTP analysis tool where you can take terabytes of data and query it using a SQL syntax in like a second. So you can't really control how we do that, but you can program what it's going to do for you, which is very cool. So as you look at the cloud, all of the tiers sort of fall upwards. And the last thing that was, one of the things that was mentioned yesterday was testing as a service. And that sort of falls up in this software as a service domain where you can ask it to do something on your behalf. So when you look at the cloud, the bottom IIS is maximal flexibility, but maximal complexity. And as you move up, you get less flexibility, but sort of maximal, programmability. And so you get a lot of, very interesting capabilities there. If you want a more in-depth talk on cloud computing, I put a link in the deck. You can check it out later. It was a whole 75-minute talk, so there's a lot more to this particular topic than I'll be able to cover here. So the question then is, okay, hey, we have all these capabilities, but why now? In fact, in the 90s, we had actually tried to do something called application hosting, where we would take your application and we'd run it off-site for you. And what was interesting is that kind of failed. There was some success in that domain, but it largely wasn't adopted. And so some of the concerns were, well, hey, I'm putting my data somewhere else. It's out of my data center. Hey, you're running my application. How am I sure you have the licenses that you're supposed to have? And so it didn't work. And so the question that comes up now is, well, why does the cloud work now? Because I'm still putting my data somewhere else. What's changed here? A couple things have changed. First, the cost is much, much lower than it was in the past, largely to the ubiquity of virtualization, and both in the Intel and AMD platforms that made things super cheap. But actually, more importantly than virtualization is economics. The whole recession has really helped cloud computing a lot, because gone are the days when you could go ask for a budget of $200,000 to get equipment to go run tests on. Now you can go pay 8 cents a minute or whatever, or 8 cents an hour, and get almost a similar type capability. So economics have really driven the adoption of cloud computing. And so where is cloud computing going? And while you can't really see this graph, just know that it's like today it's a pretty, pretty healthy sized market, around 20 some odd billion. And the projections go all the way up to 240 billion. So what you're going to see is more of your corporations are going to adopt the cloud to deploy applications. And so you're going to have to know how to test on these. You're going to have to know how to use these for testing. And so if this adoption really does happen, I believe it will happen very similarly. Now is the time to really brush up on your skills and understand what's there. So with that, I'm going to transition into some common fact and fiction. And so with that, here's some of the topics I'm going to cover. Things like, hey, the internet and the cloud are the same. Cloud computing locks me in. Actually, that's a common topic. And I invite you at the end of the talk to ask your other tough questions about cloud computing, and I'll do my best to answer them. So let's go through each of these. The first, the cloud and the internet are synonymous. I mean, hey, everybody loves a buzzword, and so all you have to do is put cloud on there, eCloud, pCloud, iCloud, whatever cloud, and suddenly things sell. But the cloud and the internet are not the same. The cloud is really cloud computing is really about enabling you to build applications, enabling you to do deployments. And what's interesting is, yes, a lot of the world, our customers are using the cloud, and to them it's just the internet. But there are differences. One example here I used of the adoption of the cloud is we have over 200,000 active applications a week in App Engine running, which is a phenomenal number, and 1.5 billion page views a day. And so you could just see this kind of growth happening. This is happening for just about everybody that's working in this space. So the cloud is not the internet, and the internet contains the cloud, but they are different. And it's all about the aspects I talked about before about elasticity and programmability. Number two. You don't have to worry about disaster recovery. Did anybody hear this? Hey, throw your stuff in the cloud and life is good? Did anybody hear this? Yeah, we all heard this, right? This is great. In fact, it's so easy to get resources in the cloud. It's actually seductive. It's whoa, I just got a database. I didn't install anything. I just put my credit card in, and suddenly I have this capability I didn't have before. But with that comes an interesting challenge, which is the way we build applications, we sort of forgot some things we should think about. And in fact, this year we've seen a couple of challenges where companies have had big downtimes where they've taken down multiple corporations that were running things in the cloud. And it was largely the way these applications were architected. It was, we all know that things are going to happen. Data centers will catch on fire, hurricanes will brush in, and so forth. And so as testers, we have to think about, are our corporations really ready for this? And are we homing our technology? Are we putting it so that it runs in the East Coast in Europe or the East Coast and the West Coast? And are we making sure that our applications are redundant or at least have the ability to come up quickly in a different location? And one company that was interesting that sort of survived some of the outages this year was a company called SmugMug, and I'd love to maybe next year we could convince them to come in and talk about how they built their applications. And while a lot of the other sites like Reddit, you heard them mentioned yesterday, were kind of down in this period, SmugMug was one that actually stayed up, and it was because they remembered this whole tenet of, hey, even though the cloud is cool and easy and fast and fluid and powerful, you still have to plan for disasters. And that means doing good engineering and really thinking about it. That's a lot at the infrastructure as a service layer. If you go to the platform as a service layer, you actually don't have to worry about tenancy as location or as much or disaster recovery, but definitely read the fine print of the technologies you're using and make sure that they are as resilient as you want. Fiction number three, I don't have to worry about location. This is a really interesting one, which is when you go and move your applications in the cloud, you have to plan on where it's going to land. Typically, you say, oh, run me in Taiwan, or run me in the East Coast, or run me in Europe. And what's interesting about this is if you deploy your application in, say, the West Coast, and your customers are all in South Africa, there's a 500 millisecond latency, ping time, roughly 200 to 500 milliseconds, to get a packet of data from the West Coast to South Africa and back. And to put this in perspective, say you have a database and you're fetching a row at a time out of it, and you have 10,000 rows, it'll take you 1.3 hours to download this data. If your same customer or another customer is now running, in California, for example, running to this West Coast database, they'll fetch that same data in less than 10 seconds. So you have to think about location as you're building your applications. It's really, you can't ignore it. Geography is also interesting from another perspective. So one is the performance aspect, but another is privacy, where privacy laws matter all around the world where you have your data. So if you have your data in the US, it's subject to US laws. If you have your data in Europe, it's subject to US or to European laws. And there's actually been this thing where world governments have started to say, hey, if you're going to contain our citizens' data, it must be within our country. And so Australia was one of these that put out this whole kind of specification for anybody building things for the Australian government about how it must be in Australia, which is really interesting. So that you definitely still have to think about location here. I also threw in things like natural disasters. So if there's a hurricane coming to the East Coast and all of your applications are running on the East Coast, maybe it's time to migrate. We've all seen that. So some other things that you have to think about. So I say the conversion of CapEx to OpEx. This is a really fancy way of saying the cloud allows you to sort of convert money up front to money you pay later. And so the way we would do testing or sort of gather equipment for testing in the past is we'd go spend a bunch of money, create our labs, and we'd go do our testing in the labs. It would cost a lot of, tens to hundreds of thousands of dollars. And that was CapEx. That was upfront money. But we don't have those budgets anymore. So how do we still do the testing we need? We need like 20 load generator machines. How can we get that? We need something to, some place to store our test data. And so that's the whole notion of OpEx. And so OpEx is like, hey, I'm going to pay you for exactly what I use, that utility computing, so the 8 cents an hour or the $5 a month for the service. And so you kind of pay as you use it. What's interesting here about OpEx looks very cool, like, oh, wow, it's only 8 cents an hour. But it's a lot like your credit card bills where you go out and you have a latte every month or every day, and at the end of the month you look at your bill and you're like, whoa, how did I spend $5,000? I only spent $1 at a time. So you do have to watch that when you go into the cloud in terms of costs and cost structure. In some corporations, you get charged for egress and ingress and lots of other things. Most corporations now don't charge you to put their data in the cloud because we want you to put it in there. And you sort of have to pay to get it out. Good marketing strategy, isn't that? Wow, I like it. Which kind of leads me into the next sort of fiction. Hey, the cloud locks me in. Yeah, absolutely it does. I don't think there's any, it's not a bad thing. You're getting something, right? Like, hey, I'm able to go in and put my applications into an EC2 instance, or I'm able to host my applications in App Engine, and yes, you made an investment, and there is some lock-in. But you have to look at the other part of this, which is one of the things Google has done is we actually don't want to lock in your data. And in fact, we've actually gone to extensive lengths to make sure you can get your data out. Yeah, we want you to stay with us, but we want you to stay with us because we're the best, not because you're stuck with us. That's not a strategy we're interested in. So if you look at something like dataliberation.org, every API at Google tells you how to get the data out. It may not be super simple all the time, but at least there's a way to do it. And so when you look at where you're going to deploy your testing and where your business is hosting their applications, really look into are you locked in or not. It's an interesting thing to focus on. So all clouds are equal. Everything sort of looks the same. It's over the wire. Everybody has an API, a JSON or a REST API or whatever, REST API or like a SOAP or XML, whatever it is. But they're not all created equally. Everybody has their different SLAs. Everybody has their guarantees of uptime. And so this is something to look into. All clouds are not equal, but there is data that you can get out. Such as here, for App Engine, we tell you things about how much uptime have we had. And so you can go look at this data and say, wow, this service looks really reliable to me. OK, this is something I can count on. Others do the same thing. I just use this example because it's a Google one. But yeah, you can take a look at this, which is, hey, there are different capabilities. There's different underlying technology. Like if you go to Azure, it's a Microsoft-based technology. If you go to Amazon or Google or other places, it's very likely some sort of Linux based technology. And so you can kind of choose what you want to do. And then the last sort of fiction is testing is easy. But I really suspect I wasn't going to trick anybody with this one. And it definitely is not one slide. So what I'm going to do is go into a bit more about testing and testability in the cloud. In fact, I'm going to talk about what I call testing cubed. So what is testing cubed? Testing cubes really falls into 3 buckets. The first 2, everybody in this room will be faced with, I suspect, within the next couple of months or year. The last one, not many people will face, but it will give you some insight into the challenges of, say, building a cloud infrastructure. So there are 3 parts of the cloud. There's testing in the cloud. This is your applications and how do I test it in the cloud. There's testing with the cloud, like the services we saw yesterday, like the testing as a service type services. And then there's testing the cloud, like things like App Engine or the Google SQL service. So let's start with testing in the cloud. It actually kind of varies by provider. And what's interesting is testing in the cloud is actually quite challenging. And it was cool to see the example yesterday around page layout and like how you could detect if the application's rendering the way you want. Largely because we have the cloud, which is sort of the back end, but you have to access the cloud through something. So it's going to be tablets, it's going to be phones, it's going to be laptops, and it's going to have your access, your entry point is going to be different for everybody. And so the challenges there are copious. I can't say anybody has solved it. In fact, you saw some solving it yesterday, so it's a wide open problem for you to go solve. We have multiple browsers, we have multiple form factors, makes testing very exciting. So some things like testing the cloud. Like if you're at the infrastructure as a service layer, it's pretty much party as normal. You have JUnit, you have PyUnit, Eggplant, Selenium. You can drive things kind of like you've always done it. It's not very different. Some things that do get different are like performance analysis. If you're running like an EC2 virtual machine, clocks lie. So if you used to look at things like, oh, I'm using 25% CPU, and that's good, those numbers are totally useless when you go to the cloud. What you really need to do is kind of pivot your thinking and actually look at rates, like how many operations per second do I get? Because that's something that is going to be immutable from platform to platform, whereas percentages just don't matter. So there's definitely deep and complex issues in testing performance. Security is important because something is different, right? Suddenly you've taken your really valuable data and applications and put them somewhere else. And so the security model is something you have to go evaluate. Do I want all users to have the data, specific users? And it's not that much different than what you have today, but you have one additional layer, which is you have access control and authentication to the control of the resources, which is different than control to your applications. And so you now actually have something extra you have to look at in the cloud. At the platform as a service layer, this is where things get really tricky, and you're kind of subject to what the vendors provide, because things like JUnit aren't going to work for you anymore. They may in some contexts, like you can run it locally. For example, if you build an App Engine app, you can run it locally and everything works, but then you push it to the cloud, and does it still work? It's a good question, right? And how do you test that? And it's hard. Some of the state of the art there today is printf. Isn't that awesome? You get email, like you got a crash and you get an email back. So there's definitely some work that can be done in that space of how to do better testing in these services. But one cool thing about platform as a service testing is you have a new tool you've never had before, which is staged deployment. You can have your current application and your next application, and you can be delivering them both. And you can say, I want 90% of all the users that visit my site to get my current one and 10% to get the new one. And you can look for failure modes. And you could use your users to find your bugs, right? They may not be happy, but you could say, hey, these are the power users. If you see them coming in, serve them this new application and get their feedback on it. So you have some new powerful testing tools that you might not have explored in the past. You'll also get a lot of monitoring. So we heard that tenet yesterday, monitoring, and it's really true. So we don't have to find all the bugs anymore, but what we can do is we can go look at data analysis, and this is an example from App Engine, where we're looking at requests per second to our application, and if there are spikes, we want to say, hey, life is really good, and people are using our application, but maybe those spikes are indicative of sudden failures, and people are just rapidly trying to get to the site because it suddenly failed. And so you can definitely use very detailed monitoring and analysis to look into failures in the cloud. And so think monitoring. So kind of moving on, software as a service. So this is more testing in the cloud. Salesforce.com does a really good job here. In fact, they have this whole framework around how you can write unit tests in their cloud, and they have goals around code coverage, and they have this thing around 70% for you to move code into production. And I actually think they're doing a really good job on this front in terms of testability in the cloud. Here was one example from their site where they're actually showing you a dashboard of how you could go in and say, hey, my application's out there, run unit tests. And so as like Salesforce iterates on their platform, they can run your tests to ensure that they don't break themselves, or you, which is a very cool thing. So there's more work that can also be done in this space. So let's switch from testing in the cloud to testing, we're testing your application in the cloud to testing with the cloud. And so testing with the cloud actually has a nice coined term now, testing as a service. And this is where you can go use other infrastructure to validate your site. And it was really interesting because we talked yesterday about, wow, wouldn't it be cool to have this security, doohickey application, or even that JScript coverage application we saw yesterday. Why isn't that just a cloud application? Why can't I just go somewhere and say, hey, go run code coverage on my app for me? Those are the innovations that are going to happen in testing as a service. And there are lots of good starts here, but totally wide open to everybody in this room to go innovate here. Some things that are out there today are like Google PageSpeed, where you can go measure your site. It'll say, hey, we noticed you have like 5 images. If you put them all together and like sort of dice them up, you could get better performance, and it has ideas about compression, and you get a lot of great data out of it. So it's a very useful service. SkyTap, if you haven't used them, this is a dev test environment in the cloud. You can run virtual machines, and they give you extra tools to do analysis on your applications. And then there's others, cloud testing. Gomez will monitor your service from all over the world, and so you can see how that person in South Africa is experiencing your application. And so there's lots of great testing as a service tools that are there, but more can be done. And largely, you're going to focus in 3 areas. And so you'll hear me always say, the 3 big are reliability, performance, and security. These aren't new. There are also lots of other interesting and important tenets around testability, like internationalization and accessibility, and those are super important. But the things that I've seen in my career that make or break an application are all around reliability, security, and performance. And so we need more testing as a service services here. So my shout out to you is go build the best that you can build and share it, because there's a lot that we could do. There's some other things you can do in the cloud. If you want to use the cloud to test your applications, and say you're building a file system like Extent 2 or Extent 4, and you had this question around reliability, like how reliable is Extent 2 versus Extent 4? Which one's better? Actually, I don't know the answer, but I threw out an experiment that could be run where you could actually go out to something like Amazon EC2, boot up 500 machines. By the way, whoever had 500 machines that you could just boot up instantly, go kind of start your test using FIO or something like that and kill all the VMs and look at how much data corruption has happened. So there's new ways you can actually go test. Like, you have an amazing amount of resources. Like load generation is a thing of the past. Like, you can generate load because you can get access for very little money to hundreds or thousands of machines, or App Engine apps or whatever to go really do things for you. So I just want to give you some ideas of what you could do here in the cloud. So a little bit more about testing in the cloud. We talk about crowdsourcing and using people to solve problems, but now that machines are so cheap and ubiquitous, I sort of throw it out there like, what do crowds of machines look like in testing? It's an interesting question. How could we use things like the Google Prediction API to do regression? Like, is my test failing or not? Like, if I've written a really good test, could I use something like the Prediction API to say, okay, hey, these are my stimulus, my input. Here's the lines of code that have changed. Here are the components that have been impacted. Here are the failure rates I'm seeing. Is there actually an issue or not? And have the Prediction API give you an answer saying yes or no, there's likely a failure here. So there are ways you can use the cloud that are very interesting. And then there's BigQuery, where you can do data mining. So we talk about monitoring. One of the challenges with that is you have terabytes of data that come out in logs, and how do you analyze this data? And so actually, Google has something that's out there. It's been out kind of in test mode for the last year called BigQuery, where you could put your data set into Google and run queries over top of it. It's unstructured data, so it doesn't have to go into a database. And so there are capabilities you can definitely leverage out there. So testing the cloud. So now I'm shifting. So we talked about testing your applications in the cloud, and then we talked about testing with the cloud. And now I'm going to talk a little bit about like how do you build a cloud, and what are some of the things that are done in actually building these types of infrastructures. First and foremost, what's interesting is there are no agreed upon benchmarks today for the cloud. So nobody really knows how to measure, is one cloud better than another cloud? So in the database industry, we had the TPC benchmark, so like TPC-C, and you could say, SQL Server, Microsoft SQL Server is better than Oracle, or you could get these comparisons. That doesn't really exist in the cloud, but there are some beginnings. So one cloud benchmark that's out there today is something called CloudStone. This is done by Berkeley. And it's interesting what they were doing here, where they're looking at something like, okay, I have a front end load balancing. I have a set of my applications running in a database. And so they're trying to get at the core of the LAMP stack. Most of the world is built on, you have your code running, you have your database, and you have your visualization layer, which is your XML or HTML output. And so this benchmark is really trying to target that, whereas like I have my front end, I have my application and my database, and you could implement something like this in any of the tiers of the cloud. There's a company out there called Cloud Harmony, and they've done some reports. In fact, they've actually gone out and measured all the clouds around I/O, networking, CPU, memory efficiency, and they try to give you data like which cloud is faster. I don't put any of the data here because it's theirs, but you can go out and look at it. And so if you're trying to make decisions of which cloud to use, that could be a possible resource. And then in terms of another possible benchmark, there's a start called Cloud CMP, Cloud Compare. Yeah, we're really creative, CMP, Compare, where we're actually trying to compare clouds. But what's interesting is nobody's agreed on any of these. So if any of you love a big challenge and want to make an impact in the cloud industry, go create something that we can all agree on in terms of how we might benchmark one cloud against another. I actually think it's something important that we need. But one thing you can also find are interesting reports. There was a report that I linked here around cloud reliability, like whose cloud is more reliable or not. And it's very old and dated data, so it probably doesn't apply anymore. But it gives you some ideas of questions to ask about reliability in the cloud. So what are some of the things Google does to test our cloud? Well, we pretty much do all of the things I've mentioned so far. We run whatever benchmarks we can find. We run different types of scaling tests and load tests. We use some of the services we've talked about to drive big load or do monitoring. And so we do quite a bit. We spend a lot of time on fuzzing. We want to make sure that if you're trusting your data and your applications to Google, that it's very secure. Fuzzing is kind of as much an art as it is a science. So we run all different types of fuzzers, like I Know This and others that are out there. And then performance, this is where we run benchmarks like, we have, Google SQL Service. Are there TPC-C-like benchmarks out there that we can run and look at and analyze how things are going? And so from a Google perspective, we're going to use the best of what we can find and the best of what we can build to test the cloud. And if you guys have suggestions and after this talk around how we could better do this, I'd love to hear them too. So with that, what's the path forward here? So a lot has been done and a lot of, in the cloud so far, and there are a lot of opportunities still wide open. Some things I really think we need as an industry for cloud is I think we need to have more of these benchmarks we talked about. I think we need to have more research. In fact, I've seen some suggestions of testing or testing as a service research, but it seems very limited right now. So if you have any impact on that, it would be great to see more research around what does it really mean to test in the cloud. I think we're only beginning to understand some of these questions. And then look at new ways to use these technologies in ways that I haven't even thought of. Like if machines are ubiquitous, why don't we use more machines? In the past, we tried to be efficient and use less of resources. But if they're so cheap, could we use more and solve the problems better than we did in the past? So with that, some things I had learned in the earlier talks were like flames and sharks were cool. So I found a flaming shark to end the talk. And so go forth and multiply in the cloud and be happy. Thank you.
Well done, Tony. Okay, we have time for questions. So raise your hand. Wait for the mic runners. Do we have somebody? Bonnie's back again. Ask a question into the mic so that the stenographers get it and we get it on video as well.
By the way, I know I speak super fast. I saw everything coming up amazingly well, so thank you.
Thank you. Thank you, Tony, for amazing talk. So when you were speaking about testing in the cloud, you mentioned monitoring as an essential part of it. So that screenshot I saw, it contained mostly like CPU, networking kind of monitoring, so mostly hardware level. Have you ever, like, and RPS, obviously, have you ever tried using like user level monitoring, sort of like some business metrics that actually affect your application? Like if I were to test Twitter, I would probably monitor amount of tweets posted, amount of tweets viewed, amount of like tweet pics posted, stuff like that. Do you think it's useful to monitor things like that? Is it actually relevant, irrelevant? So the general thoughts.
Yeah, absolutely. So what's really interesting about testing is there are tiers of testing. And the panacea is the end user customer, which is why monitoring is so important. And so do I think it's important to understand what the customer is going to do and how they're going to do it and use the applications or the services as they're going to use it? Absolutely. In fact, that's where I always start. The first thing I do is figure out, okay, what are the end-to-end scenarios that we're looking at and how do we do, how are we going to test those? And then you can kind of break it down into smaller and smaller sets of tests all the way down to what are called like micro benchmarks, where you're saying, hey, I see a lot of like I/O and CPU and memory tests. My opinion is those tests tend to lie. They can be canaries in the coal mine, which is if you have sets of unit tests, you can really see insight into what may happen in the system. But I'm sure everybody here has seen it. Like I have all my unit tests, they all run great, but my application fails. And you've seen the opposite, which is your application runs great, but all your unit tests are or your application's failing and your unit tests are good. And so you can see these dichotomies where they go back and forth. So I don't think you can test at any kind of one layer in testing. I actually think you need to go from end user customer code if you can get it, scenarios if you have to build them, all the way down to unit tests. So absolutely, we do all of it.
Okay, thank you.
Yep.
Tony, I enjoyed your talk. My name is Leonard from version 1. So I was just curious what your thoughts are in terms of performance testing in the cloud because of so many factors of variance, from internet usage, from bandwidth and all that. How much reliability do you think you can get with performance testing in the cloud?
Yeah, so my expertise actually is performance. I love all of the fundamentals, as I call them, but performance is particularly near and dear to my heart.
This question could not have been more teed up for you. He is the perfguy.blogspot.com is Tony Velum. So,
yeah, I've run multiple performance teams, and it is quite challenging. So we used to have tools before the cloud, like AMD Code Analyst. You could run on your machine and do analysis. You could use like Intel vTune. You could use, Microsoft if you're working on a Microsoft stack. You could use Visual Studio, the F1 profiler to do performance profiling. We would do things like looking at caching, performance, and I think all those things still matter, but they're really hard to do in the cloud. And as you're alluding to, and as I kind of mentioned, clocks lie in the cloud. And so the way you have to do testing in the cloud is you actually have to do it from the end user perspective, because the end user's clock likely isn't going to be wrong. And so as you look to test, you have to definitely do the constructions as we were talking before around, hey, if my application is heavily database dependent, I should make sure that all the CRUD operations work, like the create, read, update, delete. So I'm going to do lots of insert and delete testing. I'm going to make sure that checkpoints in the database don't impact my running application. And so it's hard to get to the data, but if you stick to things like rate counters, you'll do well. But my honest opinion, in fact, Anna, I don't know if she's out here today, was asking me yesterday about performance. And I said, honestly, all these other benchmarks don't matter. Like, in fact, I solve most performance problems without ever looking at the code. What I do is I sit down with a set of developers and architects. I say, let's walk through the system. And we start going through, and we're like, oh, here's our application, and we want like 100,000 users to be able to access it, and they're all going to do updates into a database, and oh yeah, and the backend database is going to have one disk. Okay, well, disks can only do about 400 or 200 transactions a second. IOPS are pretty limited. And so if you're telling me you want 100,000 of this and like the capabilities of the hardware only give you 100, yeah, you can't do it. In the cloud, what you'll notice, though, a lot of the SLAs tell you what the level of expected performance is supposed to be. And so you can build up your use case as you're going through design reviews. And it's those design reviews where you then go and create a set of test or end user scenarios that everybody agrees on. And once everybody agrees on it, now you have carte blanche to go open all the bugs you want. Driving performance is really hard if you don't have everybody agreeing, because everyone's like, yeah, it's slow. OK. But if everybody says, hey, we're going to sign up to make sure it's not slow, then you now have their permission to go drive it. In fact, I tell perf engineers the best book out there is How to Win Friends and Influence People by Dale Carnegie. If you've never read this book, it is your secret weapon to driving, testing, and in particular performance.
Thanks for a great talk. If we think about high-level services, software as a service, if you can measure things like how many API calls you can service in a second, you effectively have insight into what is important for the user. As you go down into the stack, as you get to the level of infrastructure as a service, you lose the insight as a service provider into what's important for the user. How do you close the loop between providing your service and hearing back from the customer and hearing back about what they really care about?
Yeah, that's a really deep and thoughtful question. A lot of it comes with sitting with your customers, asking for feedback. Some of it comes from understanding behavior around what customers do. For example, I'll give you some metrics. If you're building like a mobile phone application or a desktop application, for example, if you have 1 second of non-responsive application, a customer knows it. They instantly know it. Within 5 seconds, they're going to go take action. They're going to click the X to close it. They're going to go in the app manager and close it. They're going to do something. In the cloud, you have a little bit more flexibility. People are generally willing to wait up to 15 seconds. But if you go beyond 30 seconds of non-responsiveness in the cloud, people will never come back. And so it's these usability studies that you can use to understand some of this data. But you're right, in the lower tiers, you don't get any of the powerful monitoring that you get in the top tiers, which is why, while IaaS is infrastructure as a service is a great entry point into the cloud, I really think it's the platform as a service layer and the infrastructure and the software as a service layer is where we all ought to be thinking about building our applications. I think this maximal flexibility and maximal complexity, you lose too much and you spend too much time kind of rebuilding what you already get in these other layers. So I think you bring up some great points, but I think it all comes from talking to customers, looking at monitoring data, and just understanding behavioral characteristics and doing usability studies.
Thanks for the talk. My name is Brad. I work for SkyTap. It appeared on your slides a few times there. So I wanted to mention with performance testing, we deal with this a lot with our customers. And a couple things to keep in mind is people tend to focus on loss of performance or slow performance. Another thing that actually tends to bite you or bite customers for us is that you can actually get better performance than you would typically expect. So our disks in our system, for example, might be backed by a SAN, and you're going to get twice the disk throughput that you might get on a typical server. So I wanted to just raise that as an awareness factor. And the other thing is that so I know how things work in our cloud, but how have you seen, so what we found is that A/B testing over the short term, like I run a test now and then I make a change and run it again in 5 minutes, that's actually reliable. Like there's no dramatic changes happening in the short term. It's over the long term that's like I did it today and I did it in a week from now that you really lose all sort of context of how performance was changing over time. Like how have you seen that when you've tested other places? Is it reliable in the short term?
Yeah, what's interesting is generally, yeah, it is reliable in the short term, but there's something cyclical that happens on the internet, which is like, during the week, the internet, during the day has heavy usage, and you can see this in things like, how many, queries to google.com you get, or how many application activations, and then suddenly you'll get these periods on weekends where you'll move from one technology to another, and you'll see drops, right? And so one of the things that you contend with as you go into the cloud is kind of the internet weather, and it will impact your testing, which is why you have to look at long-term trends. there's things in performance, like if you look at the test back-to-back, that's great, but you can see degradations over time. It's called death by 1,000 cuts, where today it looks good, tomorrow it's only off by like 1,000%, and every day you lose those thousandths, but by a month or two later, you realize you've lost 10% of your total application performance. And so I think it comes from analyzing the trends and knowing that things can be cyclical. That's my best suggestion, is having very reliable and robust tests. In fact, on my blog, I write about how to create these reliable and robust tests. And then understanding that things can impact the internet over time and look at trends. And those things will help insulate you. And thank you, by the way, for the comment about SkyTap. You're absolutely right. Your application might have run slow, hosted locally, and suddenly you get amazing performance when it goes to something like EC2 or Google App Engine. So it's actually pretty awesome that that happens, but it can actually break your application at the same time because you weren't expecting a race condition to happen.
Hi. So you talked about different laws in different countries, but the providers also have a service level agreement. So is that something part of the testing that needs to figure out, that it's failed over in the East Coast, but now the data is suddenly coming up from a different location in the world? If you're using the App Engine as an example, have you had any experience with such kind of cases?
Yeah, so for applications tend to be more resilient to location and where they're placed versus the data that the applications access. So in the end of the day, it's the data itself. For example, pretty much everybody has what's called a CDN, a content delivery network. And so when you access a file, it actually gets geocached local to where it's getting access. So you get better performance. So like the first time you access, it might be slow, but it kind of speeds up over time. I do think it is the responsibility of the developers and the testers to understand the service level agreements of the providers and to understand, okay, the provider says we have this much uptime. And in fact, if you look, there were some really great articles written by Amazon saying, hey, you should think about how you do disaster recovery, and here's how you ought to write your applications, and think about these things in the future. And so, yeah, it is our responsibility. I don't think we can get away from it. And so it is understanding local laws, and it is understanding the agreements. And sometimes you even have competing laws. In fact, I was talking to Hugh last night where he was saying telecos have this problem where they have customer data in one country, but the customer is a citizen of that country, but they're living in another country. And one law says you must delete this user's data within 30 days, and the other country says you must retain it for 60 days. And so now they're in conflict, and so it suddenly becomes a business decision of, you're going to violate somebody's law, how do you handle that? And that is way out of my purview. Don't even ask me those questions, go talk to your lawyers. But they exist, yeah. It's way above my pay grade.
You're good at breaking laws all by yourself, Tony. Are there any more questions? All right, thank you very much, Tony.
Thank you.